This is Björn. He is the maintenance supervisor of an oil rig on the Norwegian continental shelf. Low temperatures, strong winds is what he usually encounters during his shift. Today, Björn feels quite cozy and warm though, since he decided to conduct his surveillance round from the control room, which is on shore. Björn uses 3D visualization software that enables him to walk through the plant exactly like in a computer game. He is, by the way, walking through an environment which was created by the EPC in high-complexity 3D authoring tools during the engineering phase of the rig. He simply takes advantage of what is already there. The model is always kept up to date by his engineering department, so Björn is walking through an as-built environment. His virtual rig has an online connection to Cormos. This enables him to retrieve all available data on any object in real time if he wants to. Some important things might need to be brought to his attention immediately. This could be information such as current production data, but certainly anything relating to safety. Let's switch to first-person perspective. As Björn is approaching a piece of equipment with predefined conditions, for example a certain safety-relevant item, the system displays corresponding data in the form of hovering labels or hyperlinks projected in the 3D world. We can select the piece of equipment and retrieve all object-related documentation from Cormos just in time. This could be operational data like a work permit, the detailed view of the planned maintenance activities, or any design information, such as the data sheet of the pump or its manual, including all drawings. Björn wants to learn a bit more about the pump and its relevance for the process. Using the next menu item, we can now navigate directly to the corresponding Cormos object. We will find any technical information in there. The object is selected in the Cormos tree, and we can now easily navigate to the piping and instrumentation diagram, the central document in the process industry. The P&ID already gives us some valuable information, such as the purpose of the pump in the process, but also information on all planned maintenance activities, including their due date and their status. Selecting the drive of the pump will now allow us to navigate into the electrical world. We might want to have a look at the automation and see how the drive is controlled by the PLC system. The respective function diagram shows us the logical dependencies and interlocks. Following the locking pin of the motor block, we can see that our pump is interlocked with the signal of a valve. Following the signal brings us to the valve in the object tree. Running through its sub-objects tells us that there is a preventive maintenance activity scheduled for our valve as well. Let's have a closer look at it in the isometric view to learn more about its location in the pipe run and its usage. The isometric diagram is a very easy way to get a spatial impression without 3D. Now we can use the maintenance plan to navigate straight back to the P&ID, where we started our journey through the schematic documentation. Navigation from the P&ID to the structure of work packages is, unsurprisingly, easy again. All known tasks are collected here in order to provide a reliable basis for comprehensive maintenance planning. Due dates, planned efforts and durations, as well as resource demand in terms of qualifications, materials and utilities, can be used for graphical resource planning and intercommunication with external systems, such as ERP. Barcode and RFID tagging for mobile applications are additional techniques to get fast and easy feedback from the field. The work package of Björn's pump of interest came completely predefined because it was derived from a superordinate strategy. It brings all the detail activities and necessary reports, such as maintenance instructions for the workers or the already mentioned work permit, probably the most important document of all, as it is the life insurance for people working in the plant. As Björn is of course not always up to date with every detail of the activities going on out there, he now decides to have a look at the training simulation of valve maintenance. Back in the 3D world, an animation of the necessary steps in whatever detail level displays what needs to be done in order to fulfill the requirements and constraints. Such animations can be scripted on top of the design model and will not be lost when the original model is updated. Now, let's release Björn from his duty for today. This short story was meant to give you an outline of the already available benefits of the integrated Korma system with 3D connection, focusing on owner-operators. The technology is there, and demand for such solutions is growing rapidly, especially against the background of historical and ongoing incidents in the oil and gas industry. From integrated engineering to integrated operations, Kormos makes it reality.
You